Number 7 from Monday's worksheet. A of 2. So A of 2 just means take A and plug in 2. So that'd be the integral from 0 to 2 squared. 4 minus 2t dt. So there's really nothing magic about that one. I'm just going to have to integrate 4 minus 2t. So what's the integral of 4 minus 2t?
Does integrate mean antiderivative?
Yes. It means antiderivative. It also means area under the curve, kind of depending on the problem. But I don't know what that picture looks like, so I'm going to antiderivative rather than do area under the curve. I mean, it tells me both things. It's just which thing do I want to think about to help me answer this problem. And for this one, I think I want to antiderivative. So 4t minus t squared from 0 to 4.
So when you antiderivative it, you take off the integral and the dt?
Yes, because the integral and the dt are telling you to antiderivative. So once you take an antiderivative, you don't need those anymore. I think I've said this before, but there's some freshmen, when you ask them for the square root of 16, they tell you that it's 4, but they leave the square root on there. You're like, no, you use the square root to get to 4. You use the antiderivative, the integral symbol, to get to this. So it's not on there anymore. So if I plug in 4, 16 minus 16 minus 0 minus 0. Weird when it gets 0.
Like that part, I don't
So I plug in the top one. Plug in 4 minus plug in the bottom one. So after you integrate, this is a big problem that some people have, is like they won't even integrate. They'll just plug in the top one minus plug in the bottom one. Antiderivative, then plug in the top minus plug in the bottom.
You're always going to do like that method when the original integral thingy has the limits, like 0 and 4.
Yes. I'm always going to do that method if I can take an antiderivative. Like, and a place where I wouldn't do that method is if I had a picture, then the antiderivative is going to be the area under the curve. And that's the big deal in calculus, is they mean the same thing. An antiderivative tells you the area tells you the antiderivative. And it kind of depends on the question as to how to work the problem.
So then for the prime ones, what do you do?
So for the prime ones, so a prime, that means I need to take the derivative of that thing. So I'm going to take the derivative of an integral. So the long way around is, oh, we already took the integral, now let's take the derivative. And I'm going to be like, no, don't do that. The derivative of an integral, that sort of cancels each other out. This is where we plug in the top. So I get 4 minus 2 times x squared. And then what else do I need on this problem? Times that 2x for a chain rule. And let's see if I can clean this up all at once. 8x minus 4x cubed. And so now a prime of 2 would just be plug 2 in for x. Hey, safe stop, right? We're done.
So you only do chain rule when it's the A prime?
There wasn't, like this, there wasn't a chain rule to be done on this. This was just antiderivative. This was derivative of an antiderivative, so that cancels each other out with the payment being chain rule. So I just plugged in 2. So all the work was getting A prime, and then A prime of 2 is just plugging 2.
So could you do that for every step of this, or no?
Well, I mean, I would do that.
Which one could you do it without plugging in A of 2, and then plugging 2 in?
No, for this one I kind of had to plug in 2 because it was defined as 0 to 2 squared. So there wasn't like a shortcut to get there on this one. I just had to plug in. Yeah, there was a different way, but this would be the best way to go. I had to just plug in 2 where x is.
Okay.
For this one, the derivative of an integral, a double prime is even easier, because if I have a prime, just take the derivative of that, 8 minus 12x squared, and then plug in 2 and plug in 4.
So like on the first prime one, did you not plug in 4 anywhere?
No, I did not. So if I wanted that, I would plug in 4 right there.
So you only.
I also didn't find a of 4, but it's the same process. I would just have 0 to 4 squared.
So you only plug the value into the integral when it's just regular, not the prime ones.
Yes.
Like that just sounds so random. Like,
Well, there's nothing else to do with this. Like find a of 2 is like this is my expression for a, so let's plug in 2. I don't have an expression for a prime, so I need to get an expression for a prime. Then I can plug in 2. I don't have an expression for a double prime, so I get an expression for a double prime and then plug in 2. That's a better way to say it. I have an expression for a, so I'm ready to plug in 2. It's ready to go. I mean, there's work to be done, but it's ready to go. Number 6, the graph of the function f consisting of 3 line segments is given below. Let g of x be the antiderivative or the integral or the area, all means the same thing, from 1 to x f of t dt. So I don't have to write this, but maybe it helps. The area under f from 1 to x.
I don't know what that means.
So the
Why
area,
is it 1?
pardon?
Why is it 1? Why is it not -2 if the line goes there to 4?
This problem would be easier if they started at -2. That is true. Because since they started at 1, if we go this way, we're going to be going backwards. There's going to be some negative stuff going on. So yes, it would be nicer if they had started the count at -2 where the graph starts. Agreed. But they didn't because they want you to be able to go backwards and know that that's negative. Compute g of 4. Okay, we'll have an expression for g, so I'll just plug in 4. So that's the area under f from 1 to 4. So let's see here. I don't really want to do trapezoids. I'd rather do a square and a triangle. So 1/2 base times height. That height is 3. Be careful, the triangle height is 3. So that area is 1.5. This area is 0.5. What about this area from 3 to 4? Negative. I mean, be careful how the question is asked. The area officially is 0.5, but the integral would be negative because it's below the axis. So if I add up all the areas from 1 to 4, I get 2.5. Yeah, because those cancel each other out. So yeah, 2.5. G of negative 2. So Bailey, here's your complaint. Should be rightly registered right here. So what's the issue? Why are you complaining? What do we need to do?
Find the area.
Find the area. So how am I going to find the area from 1 to negative 2? What's going on here?
It crosses the y-axis, so you have to have a negative.
I wouldn't say it crosses the y-axis, because if we'd gone this way, we'd be crossing the y-axis. I'd say we're going backwards. Like we read left to right in English and in math, but this one's saying go backwards, so it's going to be negative. Some people will just find the area and call it negative because they went backwards. Other people are like, nah, it's too complicated. Let's not go backwards. Let's go forwards. And the price we pay for switching the limits is a negative sign out front. Either way, you end up with a negative number. Let's see, that is 3 wide by 4 high. 3 times 4 is 12. So half of that is 6. So my answer then is negative 6 because we went backwards.
That's what I didn't get. I didn't know if I had to make that part, the part that's in the positive, and then the triangle on the other side negative.
It's all above, so the area is positive. What makes it negative is that we started here and at 1 and went backwards. It doesn't matter that we crossed the y-axis. That doesn't matter. What matters is that we traveled left.
So if you originally the problem was already the integral with the negative 2 on bottom and 1 up top, like you'd be going that way, so the area would be positive?
Correct. Which is why it would have been better if they'd started at negative 2, because then everything would be moving to the right and it would be positive. But we're almost never going to do that because we want you to be able to go backwards and know that it's negative. So this was a good one because the first one was positive, the second one was negative. Part B, find the instantaneous rate of change of G. So that's just, hey, do you remember what all those words mean? Hope so. G prime. IROC means calculus slope, means derivative. Like all those words go together. So I need G prime. So what's it going to take to get G prime? It's the slope of G, but I don't really have G. Instead, I'm going to take the derivative of the integral. Oh, whoops, that's right.
Also, so if it doesn't give you an equation, oh, never mind, it does.
What's the derivative of the integral of f? It would just be f. So this graph is f, but f is also G prime. That seems important. Oh, it said at 1, so G prime at 1. That would be f at 1. But just 4. Yes, those are the same thing. So that just means look at the graph. F of 1 is 4.
So 4 is the answer?
4 is the answer. Like all the hard work was up front. The easy work was, oh, G prime is the same as f. F of 1 is on the picture. F of 1 is 4. So the instantaneous rate of change of G at 1 is 4. Absolute minimum value of G. So that would mean check the endpoints. Absolute means check the endpoints. So we would need a table. -2 and 4. Did we find those already? We did. So 4 was 2.5, negative 2 was negative 6. I do need to be careful to see if there's any relative mins. That would be where G prime changes negative to positive. But there's none. G prime is the same as F. There aren't any where that happens. So the absolute minimum is that.
Is that point?
Well, let's see. The absolute minimum value is negative 6, and it occurs at x equals negative 2. Because the value is the y coordinate, the location is the x coordinate.
So if it's asking about an absolute minimum value, you have to find the relative to see if there's a relative?
Right. Because just think about like just a picture. So absolute means check the endpoints. So maybe the endpoints, right? You got to check the endpoints, but you might have a relative min that's lower than the endpoints.
Okay. And so then with that...
That's why we had to... Now this one didn't even have any relative minimum, so we weren't worried about it.
Hypothetically, if
but you got to check.
Was lower, that would be your absolute.
Correct, because you want the absolute lowest point. Like, that's low, but that's lowest.
Can we do it like last week? Send a couple people during the Asian club because they're loud,
Mm-hmm.
even though you guys are reviewing, but...
I'm about to leave to go to duty.
Oh.
So I won't be in here, so I leave that to you. They're welcome to be in here.
Okay.
But that's up to you if you trust them to be in here.
Yeah.
I don't know what they're doing or whatever. That's
Yeah.
They're welcome. It's up to you.
Okay, so for absolute minimum, you have to make a table with the endpoints. What do you do for absolute maximum?
Same thing. Table with the endpoints. But you would check relative maximums. This one you'd have to include that guy because that's a relative max right there at x equals 3.
So if that 6 was positive, wait. How did you just check the relative minimum? Like, is it because there was a negative and a negative, not a negative and positive?
So I already had these two values. That they asked me for that in part A.
Yeah. How did you just check the relative minimum?
So a relative minimum, I was looking for where G prime changes from negative to positive. Like that should be ingrained in my brain. Relative min is where the function changes negative, the derivative changes negative to positive. But for this problem, G prime is F. We have a picture of F, and there aren't any places where F changes from negative to positive.
So you'd always just look on the graph for that, like with relative minimum.
Mm-hmm.
Wait, so what's the answer? 6?
Negative 6 is the minimum value.
So then if it was a relative maximum, or if it was asking for the relative, or for an absolute.
Right. I would still have the same table, but I would also have x equals 3 on the table.
That just factors into it.
Because that's a relative max.
I thought the relative max is 1/4.
Well, okay, careful. The relative max of this graph is 1/4. But if I mean the relative max of G, this is not the graph of G. This is the graph of G prime. So you have to be careful what you're looking for. Absolute minimum of G. This isn't the graph of G, so I can't just look at the picture and pick the lowest point. I've got to do something to find values of G. It would be the same for the relative max of G. Like, this isn't the graph of G. So I can't just say, oh look, there's a maximum. Like, well yeah, that's a maximum, but this is the graph of F. A max of G would be where G prime changes positive to negative. But G prime is the same as F, so that would be at x equals 3. And so that would, if we were looking for the absolute max, I would put another entry in our table. Endpoints and relative max. One more and then I'm going to go to duty. The second derivative of G would be f prime. And once you get that, then you can answer whatever the questions are. F prime means the slope of f. You have a graph of f, so you'd be looking for slopes of f.
Because I understand that part.
If you have g prime equals f,
Or it's pretty much
you
just,
take a derivative of both sides.
you literally just take off a tick mark. And that's the
Yep,
way that
or
it
add a
works.
tick mark. As long as you do it to both sides.
Well, you always do it how the more tick marks are on the left, so you just take one off when you're going to the right.
Oh, I see what you mean.
With the big F, you
Yeah.
always just take one.
So the third derivative of g is the second derivative of f.
Yeah, you just take off a tick mark on the other side.
And the 87th derivative of g is the
86.
86th derivative of f. Now, we would never do that, but that's the pattern that you recognize.
So then whenever it's like the